in 6th grade. Thanks for having us today. What we decided to show you guys is what we've been doing at Washington STEM Academy with our 3D printers. We decided to choose to show you the gamut. We have 2nd graders all the way through 6th grade, so they're going to share with you a little bit about what they did last year. So I'm going to go practice a little bit. Both of these projects are part of our biomedical pillars, so it goes along with our orthopedic industry. In 2nd grade, some of the science standards that they have to do deals with them engineering a tool that humans use. And so to match that well with the biomedical pillars, they decided to work with a toothbrush. And so we partnered with Dr. Holler's office up the road, and we started off with a toothbrush. And the kids talked about what they wanted to change, the strengths and weaknesses of the toothbrush. And they re-engineered the toothbrush, and they were able to use the 3D printer and a webpage on the internet called Tinkercad, which is basically 3D drawing for anybody. The 6th grade, what they do in their orthopedic pillar is they have to engineer an orthopedic device. And we partnered with Zimmer, and they really focused on the orthopedic hip. So what you'll see is a collaborative effort from each one of them. They drew on using Tinkercad each part of the orthopedic device, and we're able to put it together all the way to the femur and talk about moving the femoral hip. Biomed has a great app out there where it kind of highlights the basic surgery. So with that, I will turn it over to Sam. He will talk about the technology he is holding, and then Paxton will share. We'll move down the road.
This is a 3D scanner. It scans a picture of the toothbrush, prints out on the computer, and now I'm going to turn it over to Tess. This is my toothbrush. I made it in second grade on the laptop, and then Mr. Barkey printed it out for me. Well, I made a cap for the that fits into the hip, and then some other people created a ball that fits into the cap and goes into the femur. And it goes into the femur by cutting out the femoral head, and then they insert the edge where the femoral head used to be into the head.
I created the ball that goes into the cap, and it is then connected to the thing that goes into the femur. And sometimes things don't work on Tinkercad, so sometimes there are mistakes, because my ball was too big to fit in the cap, so mistakes always happen.
We made the hip replacement. It goes inside the hip, and what Emma made, she attaches it to the hip, and then the cap goes right on it, so it moves around.
I made a cap also that fits onto the ball that connects to the big piece and then it works into the hip. It didn't necessarily fit.
And then we also have 3 students up here that started drawing something using Tinkercad at the beginning, and we're printing it for you right now to show you that the process really does not take days or even hours. That we can really do this within a 30-minute time frame. So the thing that they're printing usually will take about 7 to 10 minutes. So I'm going to turn it over to the 2 ladies in the middle, and they can kind of tell you what they drew and what's printing, what we've done for the school board, because we want to leave you for you.
Would you ladies introduce yourself before you start speaking?
I'm Kenzie Reitman. I'm Brooklyn Bushare. We created a shooting star to represent your mission, and the mission is to inspire all students while pursuing their dreams and enriching the lives of others. And so by using Tinkercad, we made the shooting star, and it was more fun. And Faith is created now. She might be done in like 5 minutes.
Yeah, so the process with the 6th grade is they each were given a different piece of the orthopedic device, and they had to collaborate together because it has to fit. And you can tell Emma was talking about, the first time we drew it, it was too thick and didn't quite fit, so you had to go back. Well, what measurements did we make that were wrong, and how can we redraw and what pieces? So through the whole process, they had to work with each of the groups and talk about measurements, and you get into a lot of geometry terms that were unintentional. We gave this project, and you talk about millimeters and geometry and height of the cylinder and the diameter and figuring out the width of the cap to get it just right. A lot of students leave with an understanding really what a millimeter is now, because if the cap is off and it doesn't fit right, we have to adjust it by a half millimeter. We also brought 2 3D printers. The one back here, if you can see that we're printing on, is the company is MakerBot, and they've produced several 3D printers. When Washington became a STEM Academy, MakerBot had 2 3D printers. By the time we purchased this one, that next summer they had 5 other versions out. And by the end of next year, they also have 3. So they have like 9 total. They don't even make this version anymore in a span of 3 years.
Which funds did you use to purchase that?
These funds, both from the OrthoWorks grant inside that budget, were OrthoWorks money, so both of them. And what's cool about it, you think of 3D printers as being really expensive, and it really is cost effective as a desktop printer. I mean, this one was, at that time, $2,500. You can't purchase anymore. The Mini, which will produce, think about something the size of your fist, $1,300. And working with both over the last 3 years, the newer models obviously work a lot better. This is a little temperamental. This one, you rarely do have certain issues with it. So at Washington, we have 3 because we really want to be a manufacturer of our ideas and of our prototypes. And one, if it takes 7 minutes to print one, we definitely want to have a nice core 3D printers. That way, when we do things like this, we can print kids' ideas and they're not waiting for it. It's not a whole day-long process. So with the cost of them going down significantly, it's very doable for sure. And a lot of people always ask me about, how expensive is it. I also brought a couple spools, which on the back, so the Mini comes with a smaller spool, and that's like $20. The bigger ones are $60. And Mr. Burr and I, we did a pretty intensive project where kids were printing a lot of things, and we just went through one spool. And it was a pretty intensive printing project. So the spools do last a while. So, and they come in multiple colors. And this is a plastic filament that comes out, but now 3D printers can produce a lot of other things as well. This is, nice for an elementary school in terms of entry level and cost. It's perfect.
Are they doing this after school? Is this during the day? When are you doing things like that?
Yeah, it's during the day. So we take what standards the teachers are teaching. Like for example, that was a science standard in 2nd grade. Engineering a tool that a human would use. So we take that science standard and we apply the engineering design process to it. Come down to the STEM lab. And for 3D printing, for us being 3 years, the first year we kind of scratched the surface because it came at the end of our first year. The second year we kind of messed around with it because we had one. But finding Tinkercad, something that kids can draw easily in 3D, has been a nice breakthrough because it really doesn't take that long and it's pretty simple to use. The 2nd graders, we're taking a scan toothbrush and adding what they thought improvements needed to be, and then we're printing it. So it really is, from a young age to an upper level that you can do that.
I think, is this fun?
Yes.
It's fun?
So how does the scanner work? If it's a 3D image, does that rotate? How does that, does it spin when you're scanning it?
What comes out of here?
Lasers come out here and scan.
And that's just like an image, like a normal image that we'd use for PowerPoint. You import it in, and there's no different kind of technology kids need to have. Import an image in, paste an image in. Once you have that image in, whether it's 3D or 2D, you can manipulate it. You can even take 2D images now and turn them into 3D. And the neat part is there's tons of people out there that have drawn images, that are way more sophisticated and talented, that we can import those in and make modifications.
Mike,
So basically 3 teams that have come together to make that. So that's
So I'm going to ask, how many teams and then how long did this whole process and study take? Is this 5 weeks of study, 3 weeks of study, 2 weeks?
We did this in the classroom to actually draw and put it together in a couple days, really. I mean, because you're building some background knowledge and talking about some anatomy with the femur and the hip, things of that nature.
so it's integrated with the class that they're doing,
Right.
and then they come see you.
Yeah, because for a 6th grade teacher to do it all, I mean, that's where I take the time to really work out the kinks of finding the web page that's the best suited for elementary kids, making sure that the 3D printers are not going to have any problems, going in and working with a collaborative group of kids and setting that classroom structure up. Until and we've talked about this. I mean, it's, 3 to 5 years for a teacher. Mr. Burden could do something with the 3D printer without my help. So it just depends on the teacher. Last year was the first year too, but once you see it once, the teachers feel pretty comfortable with 3D printers to do it. And Becky saw us to do it with history. They made totem poles out of modeling clay. This was a 5th grade project last year. Then we scanned those parts in with a 3D scanner, and then we printed it and put it together. There's a whole part with history. Why did the Western Indians use totem poles, and what do they signify? So we brought in some writing standards as well. So once you kind of get used to that, working with the 3D printer, I mean, it sounds intimidating, but it really, it's just like printing a normal printer.
In a business application, are these generally used for just making prototypes? Are they cost effective as an actual manufacturing device? Just prototypes?
Yeah, what we have is just, it's a hobby. It's what somebody that wants to get into a 3D printing hobby. I mean, we can make rings, we can make tons. The kids can, whatever they can on Tinkercad, they can make. It's pretty easy to do so. Yeah, they can make their own jewelry. So on a kid's scale, I would say no. For them, it's real.
Right.
But for something where it's industry, I think they would just use it as prototyping and as ideas to see how things would look and work.
Sorry for my ignorance, but is Tinkercad
It's a free webpage. Yeah.
free web page?
Mhm.
Okay.
Yep. So far, it's free. It's been around actually a lot longer. Something I found on Twitter while we were watching, I was reading the stream, and somebody that I follow was talking about Tinkercad. So I sent Mr. Burden the webpage, and he played around with it. And 5 minutes, he drew something with it and printed it off the next day. Whereas before, what we were training the 6th graders was Google SketchUp, which is way more sophisticated and not for the hobbyist. It's for the professional, the architect. And so we were actually spending hours during lunch training 6th graders to train other 6th graders in Google SketchUp. When we found Tinkercad, all that time is pretty much went away because it's really easy. Just drag in the block, you move it however you want it, you adjust it. You add spheres to a toothbrush, you drag things in, you make it however size you want. And, even Mr. Ray could produce something really big.
So what's the next project?
Well, in 5th grade, because they are, because these are 3rd graders now, so, but in 5th grade, the next thing we'll use with the 3D printers is we have a rocket brick, which is basically, we immerse ourselves in rocketry, and we have straw rocket launchers that we use modeling clay to create the cone on the head, but we can use 3D printers for the kids to draw whatever shape cone we want that's got to fit in the straw, so that's the next place. And again, you're talking about measurement that means something to the kids. I mean, that's the important thing. I remember when I was a first-year science teacher, all these kids don't know how to measure, and you do your standard, boring, get out the yardstick or a meter stick, and let's measure things around the classroom. That doesn't mean anything to the kid. They're not going to learn from that. But when you say, hey, design me this, and it needs to fit with this, and when they make it and it doesn't, then it means something to the kids. So now they start understanding what a millimeter actually is. I've been teaching science for a long time, and I think in my 12 years, that's probably the biggest eye-opener for me was there was a quick, easy lab. That was unintentional. We went in there just to do an orthopedic hip, that the kids understood what a millimeter was because they had that rich dialogue because it meant something.
Any other questions for our students tonight?
So when it doesn't fit, they don't let you use the glue and make it fit.
Any surgeries on the horizon here? Is that next? Orthopedic surgery?
Well, absolutely. From an elementary perspective, yeah, we can easily import a femur in,
Absolutely.
chop it off, drill a hole in it, tinker cat, and then use these pieces that they're designing. So, from an elementary perspective, I'm going to say yeah.
Awesome. This is fantastic.
Have you written any stories about your?
Last year we did with, since this is the beginning of the year, last year we did with the swimming holes. Absolutely. But that's, I mean, I think kids want to write about everything, whether it's a technical writing piece or using totem poles and creating their own fictional